Welcome to Lab to Fab Insights, bringing you the latest on key issues shaping the future of semiconductor test and measurement. I'm your host, Paul Swangard. I'm here with FormFactor's Houman Shirzadi. He is Director of Product Marketing in the FRT Metrology Group at FormFactor. He's going to share his insights on the key trends, challenges, and solutions in the silicon carbide applications market, as well as specific challenges and solutions in providing defect inspection and high-resolution measurement. Welcome to the show, Houman.
Thanks, Paul. It's a pleasure to join you.
Well, let's get started. Applications in the high-power arena are exploding, and a new platform has emerged as the viable solution for these applications, silicon carbide. Now, I understand that silicon carbide is well suited for power applications thanks to its ability to withstand high voltages, up to 10 times higher than those usable with silicon. Houman, what is it about silicon carbide that makes it ideal for power applications?
The semiconductor based on silicon carbide versus silicon are more stable and have lower current leakage at high temperatures. And this is due to the silicon carbide 3 times higher band gap. Also due to its material properties, it offers higher thermal conductivity and higher electron mobility and lower power losses.
The automotive industry has been turning to silicon carbide for high power applications. You might say automotive has driven the silicon carbide market from 1.1 billion in sales and growing by a factor of 5 by 2027. That is explosive growth.
Yes, and it's not just the electric cars, it's the infrastructure that supports it that will require silicon carbide applications, and also government mandates ensure that this market will grow way beyond 2027. In addition, applications for wind turbines, railway, and all other high power demand applications are also going to be consumers of silicon carbide.
Semiconductors based on silicon carbide are going to require new approaches to testing and ensuring reliability. What are the key challenges to testing silicon carbide?
Working with silicon carbide is not so different on the design side. It's more about how it's manufactured and how it's packaged. The key challenge we are faced with in silicon carbide applications are improving layer, or let's say thickness uniformity across the wafer, and decreasing defect density. So you need a high degree of uniformity across the wafer with low defect density, as well as thickness and doping concentration that hit the target values. Therefore, metrology and inspection techniques are required. Fortunately, FormFactor's acquisition of FRT and its metrology capabilities have provided a viable alternative for customers in those application areas.
So let's talk about some of those specific challenges, and let's start with one of the most obvious issues. Silicon carbide wafers are transparent. What challenge does wafer transparency present?
Traditionally, the equipment in the foundry is designed for the use of silicon wafers, which are not transparent and highly reflective when polished. So all the tools are taught to handle, mark, and measure these kind of wafers. Transparent wafers are not recognized. Even with TTV sensors on top and bottom looking at each other can lead to false readings. FormFactor utilizes polarizers to neutralize light passing through the wafer. With measurements on top and bottom surface, we deliver total 3D capture of the wafer thickness. This helps in determining global wafer parameters with high throughput.
Now, what other types of silicon carbide wafer measurements does your metrology solution provide?
Another big challenge is distinguishing between highly doped substrates and low doped functional layers. These layers have very similar optical properties, so it's difficult to distinguish between layers. We utilize an FTR film sensor combined with simulation models to allow for comparison of the measurements with the simulation data to determine the thickness. FormFactor has developed a multi-sensor setup called Surface Sense technology, which includes an IR microscope, film thickness sensors, and topography sensors. Our Surface Sense technology is also useful in evaluating stack thickness single wafer thickness, and bound interface thickness. And our high resolution sensors, in this case white light interferometers, are used in measuring overlay shifts in patterned silicon carbide wafers.
Well, Houman, it certainly sounds like your sensor technology enables you to make a variety of measurements on silicon carbide wafers. And you previously stated that a real challenge is to decrease defect density. This gets into defect types encountered in advanced packaging.
We have the capability to inspect from a large field perspective to high resolution, utilizing cameras and microscopes. We are able to identify damages or artifacts of the surface, such as cracks, dimples, or scratches, contaminations on the surface, like particles, and we can also identify damage or voids in a deposit material, bounding voids, lines, or lines in deposition, or stacking faults. To give you an example, our systems allow you to identify scratches with a 2D camera and utilize high-resolution 3D topography sensors to access how deep the scratch actually is. This combination of capabilities really enables you to investigate the details of defects quickly and easily.
Well, I can see why combining these capabilities into a single system can really save time and ultimately money. What other powerful capabilities do the FRT systems provide?
So we talked about measuring thickness of silicon carbide wafers before, but this very system can do the 2D inspection as well. The combination of a large field station, FTR sensors, and IR microscope really provides a powerful capability all in one system.
Is this just a single system, or are there multiple systems with different capabilities?
Our fully automated system is a MicroProf MHU. It's a material handling unit that can handle 6 or 8 inch wafers. It has TTV function with sensors and polarizers, and it can be configured with many other options. So we also have manual systems with similar capabilities as our automated systems.
Well, Houman, it looks as though FormFactor has a very complete solution for leading-edge applications in the growing automotive and other high-power segments.
Yes, we have been discussing our solutions for manufacturing silicon carbide semiconductors for high-power applications. FormFactor provides an even broader high-power solution set that extends to the test engineering laboratory as well. We offer on-wafer power device characterization systems and analytical probes to reduce time to market for new power devices and to keep up with production.
Well, that sounds like a topic for another day. Well then, it goes without saying that FormFactor has a broad high-power solutions set from the lab to the fab. Thanks, Houman.
Thanks, Paul.